Hey folks, welcome to the second video of 3.3. This is the work energy theorem. If you are crunched for time and starting to skip videos, I would just pay attention to the very beginning of this one and the very end of this one and skip the derivation. Okay, so work energy theorem is basically presented as an alternative to Newton's second law because it is the same thing with just different variables in there. So the work done by the net force on a system is equal to that system's change in kinetic energy. So basically, we know that the net force causes acceleration, and we have an equation for that we've used a bunch of times called Newton's second law. Therefore, work done by the net force is going to cause a change in kinetic energy. And so that's what we are here to look at in this video. And again, it's just an alternative to Newton's second law. So we start with a combo of Newton's second law and kinematics. And so I'm going to fairly quickly solve this for acceleration. So v squared minus v naught squared equals 2ad. That means that v squared minus v naught squared over 2d equals acceleration. So that is going to go into Newton's second law. So net force equals mass times v squared minus v naught squared over 2d. And I'm going to do something very intentional because I'm going to relate this to work. I'm going to multiply both sides by d. So I have net force times displacement. And then I'm just going to start to clean up this. I'm going to bring the 2 out. It's going to be 1/2 times m, and then v squared minus v naught squared. I can now distribute the 1/2 m. So net force times displacement equals 1/2 mv squared minus 1/2 mv naught squared. And so these equations should now all look familiar. This, on the left-hand side, net force times displacement, is the net work, or the work done by the net force. This equation, 1/2 mv squared, would be the kinetic energy of an object. And if it's v and v naught, then 1/2 mv naught squared would be the initial kinetic energy. And so we have this tidy little equation, whoops, that I messed up. The work done by the net force is equal to an object's change in kinetic energy. This is not the biggest equation of the unit, but it's one that pops up here and there when there's no worry about potential energy, especially. So again, this is an alternative to Newton's second law, and you can apply it in similar situations. Really, if mass and velocity are the data that you have in displacement, or if velocity and displacement are the data you have, then it might lend itself to this equation. And that's actually it for this video. It's very short, and we move on very quickly.